We propose SceneFactor, a factored latent 3D diffusion approach for large-scale 3D scene generation that enables controllable generation and editing. SceneFactor factors the complex task of text-guided 3D scene generation into forming a coarse semantic structure, followed by refined geometric synthesis. This enables text-guided generation of high-fidelity large-scale 3D scenes of varying sizes by outpainting 3D scene chunks from text prompts to control the synthesis process. Since content creation scenarios require editing of generated scenes, and text guidance remains imprecise for localized 3D editing, we leverage our factored semantic proxy space composed of semantic 3D boxes. This enables user-friendly spatial edits of generated scenes by basic manipulation of the semantic 3D proxy boxes, which allows for localized editing without requiring resynthesis of the full 3D scene. We formulate text-guided 3D scene generation as a factor diffusion process, first generating a coarse semantic box layout representing the text input for a scene chunk. For chunk generation, we tokenize the input text into a sequence of features. Based on the tokenized text features, we then denoise a grid of Gaussian noise representing semantic latents that decode to the proxy semantic box space. Using sliding window outpainting, we generate a coarse semantic map of a scene, comprised of coarse one-hot encoded 3D boxes of the scene layout. To generate the scene geometry, we condition on the generated semantic map, using 3D attention for a second latent diffusion model for geometric synthesis. The geometric latent space is decoded into an unsigned distance field. We synthesize geometry in sliding window fashion over the semantic condition to synthesize the full 3D scene corresponding to the semantic map. Our approach is trained on scene chunks and uses text prompts per chunk to synthesize output scenes based on chunk outpainting, using overlaps between neighboring chunks. Based on previously predicted chunks, the next chunk is generated from its corresponding text condition as an in-painting problem. We first outpaint semantic chunks and then refine them to generate the corresponding scene geometry. Our factor text-guided diffusion approach enables high-fidelity scene chunk generation, outperforming baselines in both geometric quality and text consistency. Our approach also enables synthesis of more coherent large-scale 3D scenes. Here, the input text is shown for the highlighted scene chunk. Our factored approach to disentangling 3D scene generation into coarse semantic synthesis followed by geometric refinement enables various localized scene edits that can be performed by semantic box manipulation of the proxy semantic map. A user performs only 2 clicks at the points defining an object bounding box, and optionally specifies a new semantic class. We show 5 example scene edits, including adding objects by placing boxes in the semantic map, changing object size by changing the box size, replacing objects by removing and adding new semantic boxes, moving an object from one location to another, and removing an object by deleting its box. Our semantic proxy and convolutional attention enable locality in these operations, maintaining a consistent scene outside of the edit regions. Our perceptual study shows that participants strongly prefer our generated scene geometry in both unary and binary evaluation on perceptual geometric quality. Our approach also outperforms baselines in the consistency of generated scene chunks to their text prompts. Users also indicated that our edited scenes maintain good geometric quality while respecting the edit command, as well as maintaining strong locality of edits. Thanks for watching.